Hello and welcome to my review of the machine learning workflow of the Abalone Age Prediction project. My goal was to replace a slow, costly manual process and counting shell rings with an automatically predictive model. This isn't just an academic exercise, it addresses real business challenges in sustainability and some efficiency. And today I will walk you through our key steps from preparing the data to selecting and rigorously validating models, and finally interpreting what the results mean in practice. I will explicitly connect our work to core concepts like validation and bias variance trade-off. Okay, so in the first parts, we do the data pre-processing and the exploratory analyze. We began with a deep dive into our 4,177 samples with features like length, diameter, and some viral weights. First, we do the descriptive statics from df dot described reviewed a critical issue. The minimum height was 0, a biological impossibility indicating missing or enormous data that require handling. So next, we do some visual analysis um, history through some histograms, valuing plots, and Q&Q plots help us understand distributions and identify the potential outliers. And for instance, the box plot for Vixier's weights show data points from the interquartile range, and managing these outliers is crucial to prevent them from skewing our models, especially sensitive ones like like linear regression. So we also engineered a new feature creating dummy variables for the categorical sex column. So algorithm could process it. Finally, we standardize our data. Since features like whole weight and diameter are on different scales, we use standard scalar to give them a mean of 0 and standard deviation for them for one. And this ensures that model based on distance and gradient descent like KNN or some neural networks. They aren't biased by the original scale of the measurements. And part two, modeling, validation, and the bivariance trade-off. To find the best predictor, we didn't just try one model, we implement systematically benchmarking approach. Our code looped through a suite of 8 buyer-based learners from from multiple linear lasso and range regression to KNN supports vector machines, a decision tree, and multi-layer perceptron. For each model, the workflow was rigorous. The first train on the standardized training sets, prediction on the standardized test sets, the intent transform the prediction back to the original ring scale for interpretation, and evaluates using a consistent performance function that calculates MSE means absolutely error and R squared. And last but not least, we do some visualize with press vs actuals scatter plots for a quantitative check. And this is where the bias balance trade-off become tangible. Our multiple linear regressions serve as a high bias baseline. It results in an MAE of 1.61 years and an R square of 0.53, and it tells us a straight line model that was too simple. It couldn't capture the complex growth patterns. So in contrast, a single decision tree linear regressor can create some more complex nonlinear rules, potential fitting the training data too closely, which leads to high variance. The question was, could we find a model that balanced the trade-off better? The answer was ensemble methods. While our provides code loops shows Bayes learners the logical next step, and a common best practice is to employ random forest or gradient boosting. These ensemble these ensemble methods build many trees and aggregate their predictions. This approach reduce variance compared to a single tree and reduce bias. And compared to linear regression, striking a superior balance, we use the validation sets to tune these complex models and select the best performance before a final check on the how out test. And the last part was interpreting results and real world implications. Let's interpret the linear regression results as we provide the clear insights. The model's coefficients tell a story. For example, the large positive coefficient for shark weights and the negative one for visor weights might reflect complex biological relationships as simple linear model structures to disentangle. But the key performance metrics are universal. The MAE for 1.6 years is practical benchmark. It means that even a simple model can, on average, predict an abalone's age within a 1.6 year margin for determining some maturity often adds 3 to 4 years that starts to become actionable intelligence. Now let's solve the original business challenges. The first one, um, scalability and cost. Automatically, this prediction eliminates the manual microscope bottleneck, turning attacks of hours into seconds. The second one, sustainability. A reliable batch process model enable data-driven harvest or not decision at scale and protecting some junior populations. And the third one, stakeholder trust. These important output from tree-based models are powerful. We can show farmers, see, the model also heavily relies on share weight, mirroring their own experience. This builds trust in AI. And the fourth one, compliance. A standardized algorithm provides consistent, auditable records, strengthening some compliance reporting compared to variable manual counts. And in summary, this project was a full demonstration of the supervised learning workflow. We perform on some critical data processing, including standardized and outlier management. We implemented a model validation framework to make fair comparison across a diverse set of algorithms. We critically empirically navigated the bias variance trade-off, moving from a high bias linear model to more strategies like ensemble trees to achieve a better generalization. The outcome confirms that the machine learning offers a viable, valuable path for the industry. It transforms a subjective, specialized task into an objective, scalable tool, and future work could involve more advanced future engineering or deep learning architecture for future reduce error. So ultimately, this project shows how um, method methodical ML approach grounded in business needs and some data science and robust validation can create some tangible results to the real world problems. And thank you so much.